This call is now being recorded.
Hello, guys. Welcome to the first of our Excel in Science. So I think 2 weeks has passed. At this juncture, you should at least complete your Sengkang Secondary School 2023 end of year examination. The idea that we have this for your Excel in Science for both physics and chemistry is so that you actually expose yourself to more questions. You practice the question, then you actually realize that there is a lot of pattern in the questions that's being asked, and they are actually doable. So it's okay if you have struggled. What is more important now is what is your next step, right? As you clear up towards the end goal, which is N levels next year, which is going to happen sooner than you think, right? By the end of the year, it will be only be 9 months towards your N levels in September. Okay, so as we move on, we want you to have a strong foundation. So use this time wisely, use this time well, so that you can build your foundation for your Sec 3 topics, and that gives you a very good start, uh, and it gives you a very good platform for you to jump all the way and make sure that you're ready for your N levels. Okay, so let's look at the questions that it is inside this paper. If you are strong, you feel that you have done well, especially those who pass, you should try this paper first. And I hope all of you have at least attempted. If you cannot, then use this opportunity to follow me in doing the paper. Okay, so for the first few papers, I will actually have a lot of hand holding. I will write a lot of things down. The next few, I think you should already for the last few papers, maybe you should be able to do it yourself. You should already have pick up certain habits, right? So it's important for those who are weaker that you follow me. So that's a very important criteria here, is that you must follow and model after me. Okay, so that you actually pick up the habits and the thinking processes in doing the questions. Okay, so this is a very important. Okay, now which row, question number one, which row shows the physical quantity and the correct SI unit? Okay, this one you don't have to model after me, but for you to actually know that this is in chapter 1, so if you want to make notes, you can make notes from this. You can have your chapter 1, chapter 2, chapter 3, all the way to chapter 8 that you have learned, or chapter 9 that you have learned, right? We have learned from chapter 1 to chapter 9. You can have your own separate, have your notebook, right? You can start making notes for these chapters. And then as we do questions, you can write down the questions and you can write down the notes, right? So now you can link the notes and the questions together. Okay, so which row shows the physical quantity and correct SI unit? This question, physical and quantity and SI units, um, it's a very broad thing, but we can actually know that we know that the physical quantity is break into two. We have the derived and your base, right? Okay, so your base quantities, if let's say they're asking for base quantity instead, remember your base quantities is Lionel Messi cheated at the tournament, LMCATT. Okay, so this is one thing that I want you to know. Your LMCATT should come naturally to you already. Okay, so what is LMCATT? This is your Lionel Messi cheated at the tournament, right? Okay, Lionel Messi cheated at the tournament. This is length, mass, current, amount of substance, time, and temperature. Okay, so length is meter, mass is kg, current is ampere, amount of substance is mole, time is seconds, and temperature is Kelvin. The famous two in this that you should be familiar with, especially that they like to test, is these two. Okay, the number one is mass, Why? Because it's kilo. The rest, no prefix before it, right? Only mass has a prefix, which is kilogram. And temperature, because you are so used to degrees Celsius, you must remember that the SI unit is actually um, Kelvin instead. Okay? Then now the next one is, which symbol indicates the prefix mega? Which symbol indicates the prefix mega? So here there are whatever way that you want to remember, but one of the things that I bring to my class, okay, is this for prefixes is that girl made kids delicious cookies, make delicious cookies making me naughty. Right? That girl made kids delicious cookies making me naughty. Okay, so what is T? T is your tera. This is times 10. Everything times 10. Right? Just need to remember it starts with 12, then minus 3. 9, 3, 6, 3. 12, 9, 6, 3. Sorry, not 3, 6. 6, 3. Then after that, -1, -2, 3, 6, 9. -3, -6, -9. Okay? And so from here, which is the prefix for mega? Tera, giga, mega. We know that it's A. Yeah? Okay. This is the answer. Just now for question 1 also. The answer would be, this is wrong. This is wrong. Length is not meter squared. Sorry. Electric current is correct. Right? So B is the answer. D is also wrong. Right? So you can do with me amount of substance. This should be mole. This should be meter. And this should be Kelvin with a capital K. Let's move on to the next one. An apple falls to the tree. What is the approximate acceleration of the apple during its fall? Okay, this is a very typical question. Okay, this is in chapter 3. Yes, this is in chapter 3, right? Where they talk about something that is falling. When something is falling, and there is no air resistance, right? If they tell you there is air resistance, then it's different. But when there is no air resistance, you must always remember that the acceleration is 10 meter per second squared. A is equals to 10 meter per second squared all the time. Doesn't matter where, doesn't matter at which place, acceleration is always 10 meter per second squared. If there's air acceleration, if there is air resistance, then if there is air resistance, you use F net equals to MA. Okay, but in this case, the case of the question is no acceleration. Never mention anything about acceleration anywhere. Okay, so since there is no mention about acceleration, then we know that here the acceleration will be 10 meter per second squared. So questions like to ask you, okay, if there is a apple here, and apple here, A, B, C, D. At all junctions, the acceleration at A is equals to the acceleration at B, is equals to acceleration at C, equals to acceleration at D, which is 10 meter per second squared. This is the acceleration due to free fall. This is a very typical question. You must be able to make that link. So anything that is falling, you know that the acceleration is 10 meter per second squared. Okay? Now, question 4, the graph shows how the speed change with time. This is chapter 2, kinematics. They love to test graph. They love to test graphs. You will definitely find a graph question no matter which paper you do, there will definitely be a kinematics graph question. Okay, how do we approach kinematics graph question? Standard, always start with writing DSA. You must start with writing DSA. Okay, you must know when there is direction. What does DSA means? DSA means distance, speed, and acceleration. Okay, so that is very important. DSA, distance, speed, and acceleration. Okay, so from the what do you call this? From the you can actually get your D, S, and A from the axis of the graph. So in the case of this graph, okay, from the axis of this graph, you can actually see that the axis is a speed time graph, right? So from here, I go and circle speed. What is the importance here? Importance here is that whenever we want to talk about acceleration, look at the gradient. And whenever we want to talk about distance, we look at the area. This, every time you have a velocity time graph or you have a kinematics graph, you must start with this. Go and write your DSA. Always when you know that when it goes to the right, we're looking at gradient. When it goes to the left, you're looking at area. Every time if you start with this, you're going to give yourself a very good chance to get all correct for the question. Okay, you're giving yourself the best chance to get yourself the full marks for the question. Okay, so which statement is true about the motion of the car? The car is moving decreasing acceleration. So the first option they are talking about acceleration. So I need to look at the gradient. So how does the gradient look like here? So I can see the gradients like that. It's getting gentler and gentler, right? Okay. So if the gradient is getting gentler and gentler, is the gradient increasing or decreasing? Okay. So that's the question you want to ask. Gentler is equals to increasing or decreasing. And when it gets steeper, increasing or decreasing. So whenever the gradient is getting gentler, must know that is decreasing. And if it is getting steeper, the gradient is increasing. Okay, so if the gradient is getting gentler, that means the gradient is decreasing, means acceleration is decreasing. So A seems to be the right option. Let's look at the rest. We just confirm the rest. Car is moving in decreasing speed. So speed, I'm not looking at gradient, I'm not looking at area, I'm looking at the graph itself. The graph I can see is actually increasing, ma. So speed is actually increasing, right? So this is wrong. Car is moving increasing acceleration. This is wrong. We have talked about this. Car is moving with uniform acceleration. Uniform means no change, right? So the gradient needs to be no change. So that will be a straight line. It should look like that. Your diagonal lines, right? These kind straight, right? Then we can say that if this is a speed time graph, draw, right? If these are speed time graph, in these cases, you can see that the gradient will change. It's always like that. It's always this, it's always this way, right? It's always this way. No change, straight. Because there's no change, acceleration is also uniform, right? Okay, can see, Chapter 5, or not, question 5. A bowling has mass 5 kg is brought from the earth to the moon. Gravitational, every time they give you when they give you information, bowling ball has a mass of 7 kg is brought from earth to the moon. So now we know that mass is 7 kg. You all memorize formulas. I know you all know W equals to mg. Now translate the words into your formula. So mass equals to 7.0 kg, immediately write m equals to 7.0 kg. Okay, the Earth has a gravitational field strength of 10 Newton per kg. Earth has a gravitational field strength of 10 Newton per kg. So immediately write G of Earth equals to 10 Newton per kg. While the Moon has a gravitational field strength of 1.6 Newton per kg. So this G of Moon is equals to 1.6 Newton per kg. Which of the following is true when it is on when the bowling ball is on the moon? It's a very standard question on mass versus weight. So this is a chapter 3 question. Okay, when on what this is on mass versus weight. Okay, so you can actually go and write down chapter 2, you can write kinematics. Chapter 3 here you can go and write about acceleration of free fall. Acceleration due to field free fall. Then here you can write prefix. And then here you can write about base quantities. Okay, so these are the different in the whole big chapter. We are the question 1 we are looking at base quantities. Chapter 2 we are looking at prefix. Chapter 3 we are looking at acceleration due to free fall. Question 4 we are looking at kinematics graph, right? And then question 5 you're looking at mass versus weight. Anyway, so the main thing about mass versus weight is that mass, we know that no change. Weight is dependent on G. W equals to mg. So which is true of the bowling ball when it's on the moon? We know mass has to be remains the same. Weight, we can see that W is equals to mg. So if G decreases, weight will also decrease. Answer is D. Can? Question 6. Diagram shows a wooden block of mass 750 grams. Mass of 750 grams. So I'm going to extract this information first. M is equals to 750 gram. Right? And just to have good habit, go and convert it to SI units. 0.75. Just have that good habit. Okay? And then what is the density of the wooden block? So they give you 5 cm, 2 cm, 10 cm. You can convert this 0.05 meter, 0.02 meter, 0.10 meter. Okay, density of wooden block. We are using the formula rho is equals to m over v. Mass over volume. So now I have mass, I don't have the volume. So this I have, I don't have volume. How do I get volume? Go and calculate your volume. So what's your volume? Is 0. You look at this, you're using cm, 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 right? So we use the cm one, 5 times 2 times 10. This is 100 cm cube. So 750 divided by 100 cm cube, the answer is A. See? So this is 750 divided by 100, you get 7.5. Okay, so this is an important formula that you need to know. Okay, just like how W equals to mg was an important formula, right? Rho equals to m over v is also an important formula. Okay. Question 7. 3 objects placed in a container of liquid one after another as shown. P, Q, R, which shows the correct order of densities of the 3 objects from lowest to highest. So we know that lowest density will float, highest density will sink. So which one sinks most? P sinks most. So, and then Q floats. So the answer is P. Question 8. The diagram below shows a brick with rectangular sides resting on a table. The brick is now turned so that on the table on its so that it rests on the table on its largest side. Okay. Which is true about the force and pressure? Force and pressure. So you need to ask ourselves, what is the force and what is the pressure? What is the force that's being exerted on the table? Right? In this case of the block, what is the force acting on the table? Right? It comes from the brick, right? This is the weight of the brick, right? Right? Whereas the brick here also is the weight of the brick. So for the force, is there a change in the weight of the brick or not? When I stand up and lie down, when you stand up and when you lie down, got change or not? No change, right? So in terms of force, it remains the same. Pressure now. What is the formula for pressure? P is equals to F over A. Right? P equals to F over A. So if the force is constant, right? If the force is constant and area increases, what happened to the pressure? It decreases, right? Because it says it goes to the largest side now. So area is increasing, pressure will decrease. Say C. We move on. So this is question 7. Sorry, question 7 is under chapter 3 also, under density. Question 8 is under chapter 3, under the topic of pressure. Question 9. Which method is not a way to reduce the negative effects of friction? This is under chapter 4, which is on resistive forces or on friction. Okay. Negative effects of friction. Using ball bearings reduces the negative effects. Using lubricants, using non-slip surfaces actually increases friction. So we are actually not reducing, but we are actually increasing the positive effects of friction. So the answer is C. This one you have to go and learn yourself. Okay, using wheels also reduces. Okay, so question 9 is this. Question 10, below show 4 stationary balls view from the top. Some forces are applied on each ball. Every time you see the word stationary, don't move. Constant speed. Okay, let's quickly write this down. Stationary. When you see the word stationary, not moving or constant speed, uniform speed, all this, something should immediately come to your head. The thing that should immediately come to your head is that all these terms, constant speed lah, uniform speed lah, stationary, is that F net equals to 0. A is equals to 0, so F net is equals to 0. So the acceleration is 0, so your F net equals to 0. So immediately I see 4 stationary balls viewed from the top. 4 stationary balls. I'm going to write F net equals to 0. What does F net equals to 0 means? That means all my forces are balanced. That means whatever force I apply on the right side must be equal to whatever force that is applied on towards the left. All the forces are balanced. So you can see A, 2 newtons to right, 2 newtons right, 0 newtons. F net equals to 0. This one, 2 newtons up, 2 newtons to right. This thing will actually move this way, right? I pull up, I pull to the right. Eventually, it will move in this direction. Yeah, this one, pull down, pull to the right. So it will go to this southeast direction. This one, 2 newtons to right, 2 newtons to right. It will just move 4 newtons this way. Correct or not? So the idea is A. Now I'm going through the process. Eventually, when it comes to this kind of question, you should just take one look at the free body diagram. I know that the answer is immediately A. Why? How did I help myself? I helped myself by writing this. F net equals to 0. When I saw the word 4 stationary balls, I saw the word stationary, I knew F net equals to 0, A equals to 0, F net equals to 0. Therefore, I'm going to look at which one will give me the balance forces. Okay, so this is on chapter 4. when we look at balanced versus in unbalanced forces. Okay. Question 11. A hair dryer uses 90,000 joules of energy in 180 seconds. Again, information. Hair dryer uses 90,000 joules of energy. So now I know that E is just equals to 90,000. In 180 seconds, this is a time, right? So time is equals to 180 seconds. So calculate the power generated by the hair dryer, right? Calculate the power generated by the hair dryer. So what is the formula for power? Really, I'm going to write down. Power is equals to work done over time, or power is equals to energy over time. I'm more familiar with this. Power is equals to energy over time. So do we have energy here? 90,000. Yes, I have 90,000. Do we have time? 180. Fantastic. Immediately you just apply the formula. So you have 90,000 divided by 180, you will get 500 movements. Okay. So this is on chapter 6 on energy. This is on chapter 6, more specifically when we talk about power. Question 12. Which statement describes the movement of particles in a liquid state? This one is on chapter 7, kinetic particle theory on FAM. Right? Forces, arrangement, and the forces of attraction, the arrangement of the particles, and the movement. Okay, so by now, okay, you need to memorize. This is something you need to help yourself. Remember, when we talk about solid, liquid, and gas, I must talk about FAM. What is the F? What is the A? What's the M? Talk about your FAM. Talk about the FAM, man. Right? So force is your strong forces of attraction between the particles. Liquid, still less strong or weak. Weak forces of attraction. Gases, it is very weak forces of attraction. Arrangement for solid, we know that it is, what's the arrangement? How are solids arranged? Something that you must memorize. We know that they are closely packed. They are in a orderly arrangement. For liquid, they are less closely packed. Still closely packed, but less. And they are in a disorderly arrangement. Gas is very far apart. Solids, how do they move? They vibrate about its fixed position. The word that you must mention is vibrate, about fixed position. Liquids, how do they move? They slide past each other. Slide past. Gas, they move around. They move freely in all directions. Okay? So this is your FAM. You must memorize your FAM. This is the cornerstone of this chapter. Okay, so you must know your FAM. So they're asking for movement in liquid state, the M in liquid state, which is slide past each other. The answer is C. Okay. Question 13, which best explains why gas can be compressed? Can be compressed means that there is no fixed volume, correct? Okay. So now we know that every time we talk shape and volume. Shape, why it takes the container, why it takes the shape of the container, right? They will ask you, why is it fixed shape? Why does it take or why is it no fixed shape? Or why does it take the shape of the container? Or volume, why is it fixed volume? Or why is it incompressible? Right? Sometimes they talk about compressibility, right? Volume, they will talk about compressibility. It is important you need to know compressibility. Okay, it is important to know which one to use. Every time when we talk about volume, right? Sorry, these two is together. Every time we talk about volume, always remember when we talk about volume, we need to talk about why they cannot be squeezed further, right? So when you think about your classroom, if everyone is so close together, you cannot push another, or think about the MRT, right? Why cannot add in another person? Because everyone's already packed together. It's not that because everyone is vibrating by its fixed position or everyone has a fixed position. If everyone's at a fixed position, somehow I can be able to squeeze one person in. But the more important one is that the fact that everyone's already too close together. Understand? So that's why the volume cannot be compressed. Okay? So that's why when we talk about volume, we must talk about the force of attraction and talk about its arrangement. But when we talk about shape, if you think about water, how come they can take the liquid? It's because particles can move about, because you are fluid. So imagine your classroom sitting. If everyone has a set seat, right, during exam, everyone has a set seat, then you will always be in that square shape. But if everyone can move around, we can move the tables around, we can take different shapes. The classroom can look in different shapes. You all can be sitting in different shapes. But if the tables are fixed because of the exams, right? So you cannot, we have fixed shape already. So that's why when we talk about shape, we must talk about movement. Think about you moving the tables. Okay? So F plus M. Okay, so this is something which also must memorize. Okay, must memorize. Okay. But trust me, if you are able to get this, you will easily get maybe 3-4 marks in the exam. 1 mark maybe MCQ, 2 marks maybe when they ask you to explain, or 3 marks, maybe 3 marks in your exam. 3 marks is 6%, can determine whether you jump one grade or not. Okay? So no fixed volume. We need to talk about the F and A. So slide one another is not about arrangement. Particles in gas are not closely packed. This is most likely it, because you're talking about arrangement. Particles in a gas are arranged in a disorderly manner. Gas particles are arranged in a disorderly manner. It is random. Okay, particles gas held by strong forces of attraction. Okay, the more important one is the fact that we can move the tables. Right, so that's why we talk about the movement. Okay, the arrangement. Sorry, the more important bit because it can compress is because basically so much space in between, right? So I need to talk about the arrangements itself, how closely packed they are. Which statement is or are true of a solid when it is heated below its melting point? Okay, below its melting point. So it's not at the melting point yet, it's going to below the melting point, right? So every time particles move faster, average kinetic energy. Sorry, this is chapter 7 also. Sorry, just quickly do this. Chapter 7, this is on properties. Okay, properties of solid liquid gas. Okay, question 14. Which statement is or are true of a solid when it's heated below its melting point? So we know that when it's heated below its melting point, temperature will increase. Correct? Now, every time I see temperature increase, temperature decrease, I'm just going to write IE or even a change of state, melting point. So, melting point, melting point, boiling point, freezing point, condensation. I'm just going to quickly write this. IE, what is IE? IE is called internal energy. Internal energy of the whole substance. We break it up to the kinetic energy of the particles and the PE of particles. So I'm just going to quickly write this. Quickly write this down. This one I spell particles wrong. It's particles. Okay. And we must relate the average KE of particles is related to temperature, and the average the potential energy of particles refers to average separation. Average separation means the state that the particles are in. What is the state? Solid state, liquid state, gaseous state. So when we talk about being heated below its melting point, I know that temperature will increase now. Below melting point, temperature will increase. So kinetic energy of particles increase, internal energy of particles increase. It will look like that. So let's see. All the particles move faster. This is wrong. Yeah, it is on average, but not all. Okay, so always remember here we're talking about average PE, average KE. Okay, on average, all particles move faster. This is wrong. On average, the particles move faster, or all the particles don't move faster. On average, particles move faster. The average kinetic energy of the particles increase, correct? Internal energy of the solids increase. Good. 2 and 3 is correct. So 1 is wrong. The answer is C. Okay. So if you have a doubt on this, please come and clarify with your teacher. This is under IE, internal energy. I will write this now. Okay. Okay, you can start curating notes based on questions like this. Okay, and then put the categories like how I've been making categories. This is to help you. Okay, question 15. The graph shows the temperature of substance in the gaseous state that is cooling gradually. Every time you must be happy to see these graphs, because actually now you may find it that it is quite difficult. But every time I get this graph, every time I don't get the answer. Every time I see this graph, I don't get the answer. It's fine. Right now you may not get it, but trust me, keep practicing this. You will see that the answer is always standard. Okay? So under chapter 17, we talk about heating or cooling curves. And again, when I see this gaseous state that is cooling gradually, so I know that this is a gaseous state, by the way. Quickly just write gaseous. So we know this is okay. So gaseous state that is cooling gradually. I see this graph, immediately I just go and write what I did before. Quickly write IE, KE, PE. You must remind yourself of particles. We're talking about average here. Okay, and then this is related to temp. This is related to state. Okay. Now, at WX, it is a change of state, correct? Because this will either or. It's always a either or. Either change in KE or change in PE. Okay, so at this state, there's no change. This is a change of state. Why? Because there's no change in temperature. The particles are actually, they are strengthening their forces of attraction, right? They're gaining energy to, they're losing energy to strengthen the forces of attraction, right? So this is the condensation. So this is liquid. So this is freezing. Okay, so the answer is fine inside. Question 16 shows a glass of water in the room being added with ice cubes. Which statement is true? So you know that ice cube water, they're going to test about something about heat. Just quickly draw how the heat energy flows. So it's always on higher temperature to lower temperature, right? So I'm just going to quickly draw this. Okay. That shows energy is actually is transferred into the ice cube from the water. Energy, which statement is new? Energy is transferred from the water to the ice cubes, no? Yes. Yes, this is correct. B, energy is transferred from the ice cube to water, no. No energy transfer is wrong. In thermal equilibrium also wrong. Why? Because confirmed ice cube is about 0 degrees Celsius. Right? This is glass of water in the room. This is room temperature. Let's go to the next question, chapter 17. This is in chapter. Still, this is chapter 7. Right, this is transfer of thermal energy or internal transfer of energy in internal storm. Question 17. Boy making a cup of tea left the spoon in the hot cup of tea. Metal spoon. Hey, they suddenly use the word metal, right? I see this, I think ding 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 ding. I should know that we probably need to talk about conduction. So I see the word metal in a temperature kind of question. Probably going to talk about conduction. Okay, so this is chapter 8, thermal processes. Chapter 8, this is on conduction, sorry. After sometimes the boy find that the spoon is now hot, which diagram shows how energy is transferred on conduction. We know that conduction starts from one end, it ends, and it finish, it vibrates all the way to the other end. So before heating, it should not move so much. After heating, it starts to move. So C and D is out. Then there is a movement, right? There's a collision, right? It should collide. So the answer is A. It cannot be B because cannot start from here then suddenly collide to the left, right? It must be a flow. Okay. Question 18. Small cork is fixed with wax onto a metal plate. Electric heater is placed close to the plate. After some time, the wax melts and the cork drops off. Also chapter 18. Also chapter 8. This one is on still conduction, convection, radiation. So every time you see a gap, you must think about radiation. You see a gap, something that is there is either they are far apart, they're not in contact with each other, radiation. But when they start touching each other here, touching, right? This one means is conduction. So they are talking about how the electric heater reach the wax. First part is radiation. So B and A is out. Then across the metal plate has to be conduction. Answer is sorry. Answer is C. Question 19. A container filled with water is heated from the bottom. Which container produce the convection current? This is on convection. So chapter 8, convection. Always remember convection current starts from the heat source. It will, if it's a heat source, it rises and it sinks. The answer is D. Okay. It cannot be C because all the waters here, they will expand, right? So they will actually rise first, then after that they go down. Question 20. Also chapter 8. This is on radiation. How do I know radiation? Check which of the following clue is the best radiator. They talk about radiator or thermal energy. Every time you see this, they talk about dull black, talk about texture and color, right? This hints that it's radiation. So always remember when it talks about radiation, a few signs. Number one, there is no contact. Number two, when you see TACT, factors that affect radiation, your tact. You must have that in the back of your hands. What's tact? Tact, TACT, is your texture. Sorry, your temperature, temperature difference, your surface area, your color, and your texture. Must memorize this. So the best emitter or absorber and the worst emitter or absorber, the higher the temperature difference, the greater the surface area is the best. The greater the surface area, the better the absorber of radiant of thermal energy. Okay, the color or thermal radiation. Color, you want black. Texture, you want rough or matte. Sometimes they call it matte. Okay, for worse, you want white or silver. And then you want it to be shiny or smooth. Okay, this is another thing that you must remember. TACT. It's not difficult actually. This TACT, all this. So every time you see radiation, just think about TACT. It happens very often in life. So best radiator, we want the best color and best texture is black and rough or matte. So matte is actually your dull colors. It's a dull texture. That's okay. So we continue. Please try go and make notes from this. It's not just merely copying, but trying to understand. If there are parts where you don't understand, please come and clarify. We will upload the paper 2 answers soon. Okay. Thank you very much, everyone. Have a good day. Bye-bye.